Our sun is a star. By looking at the light that's coming from our sun and comparing it with the light that's coming from elements that we find on Earth, we know that our sun is 75% hydrogen. Hydrogen is made during the Big Bang. Every hydrogen atom in your body was made during the Big Bang. Now, gravity pulled all those hydrogens together, squeezed them together, crashing into one another, making lots and lots of heat and pressure, and that heat and pressure made one element turn into another. Hydrogen turns into helium. Now, it's been taking 6 billion years so far, and we've got another 6 billion years to go with our sun. So don't worry about it. Our sun's not going to burn out tomorrow. The pressure squashes the hydrogens together, 4 hydrogens squashing together to make one helium by fusion. Fusion is atoms squeezing together to make bigger atoms. The energy from fusion is what makes our sun so hot and bright, giving us all of our light. As years go by, the amount of hydrogen slowly goes down and the amount of helium comes up. Hundreds and hundreds of tons every hour. But the sun is big, very big. Hundreds of Earths could sit inside the sun, well, if it was hollow. The protons from the hydrogen, because hydrogens are made from just one proton, the protons squash together to make the neutrons. Now, after 6 billion years, there's going to be a nuclear explosion, a really big nuclear explosion. The outside of our sun will become a red giant. The atmosphere of our sun will become so large that the Earth will be inside the red ball of the red giant that our sun will become. And then it will go all sort of fizzly and nothing much, and it become a white giant, which is just giving off light because it's hot, still a bit hot. And then it becomes a brown giant, and then it's just not very exciting. But if our sun was bigger, if our sun's core was 1.4 times bigger, then instead of going from a red giant into a white dwarf, then we would get an enormous explosion. What happens is the red giant squeezes out, becomes a super red giant, and then there's a crushing in, and the crushing in causes a rebound. And it's that rebound that we see as a bright star, a new star in the sky. And new is nova. Greek, Latin, I think Greek. Nova becomes nova. Nova is what we call something that's new in the sky. And because it's new and very bright, especially if it's close, it's called a supernova. Supernovas go off all the time, but they're so far away that we don't mostly see them. If there was a supernova went off in our Milky Way, close to us, we'd know about it. There'd be a new star in the sky. You'd be able to see it during the daytime. Supernova are fab. If the sun is 4 times the mass that it is now, rather than it becoming a supernova, spraying elements all across the universe, well, that's how we got our elements. All the elements that make up me and you came from a supernova. No, not the hydrogens, not the heliums, there's very little helium inside you, but all the bigger elements, the iodine, the potassium, the calcium in your bones, they came from the explosion called a supernova. And those atoms got spread around and mixed up and then made into new planets, and that's where your atoms came from. Moby sang the song, the You Are Star stuff. If it's even bigger than a supernova, then the crushing down causes not just the electrons to crush into the protons to become neutrons, making a neutron star, which is what you got from that supernova. Bigger than our sun, 1.4 times bigger than our sun. You get a neutron star. Small, well, about the size of our Earth, but hundreds and hundreds of times smaller from the original star. All the atoms crushed together. No more space between the neutrons and the protons and the electrons whizzing around the outside. All the electrons are crushed into the nucleus to give you electrons plus protons gives you neutrons. It's a neutron star, a star made up entirely of neutrons. If it's even bigger than that, 4 times bigger than our sun, you get the neutrons on a neutron star crushing down even further to give you a singularity called a black hole. There's only 2 things wrong with black holes. Well, they're not strictly black because there's a little bit of radiation coming off them. And also, they're not holes. You can't go into them and then go somewhere else or through them. No, it's a singularity. Right way up. It's something singular, very, very small, single piece, smaller than an atom. All of the atoms have crushed down, all the protons and neutrons have crushed down to something smaller than a dot. It's called a singularity. That's what a black hole is. The protons, the neutrons, crushed together are no more. Good. And that's how you get black holes. If you like my videos, press like down here. If you double like my videos, press subscribe down here. My name's Good Luck Gary. I'm a tutor in Hong Kong and I teach in the international schools. I've been doing it for a few years. If you want to know more about me, this is my card. Oh, it's in focus. It's in focus. It's in focus. You can find my Facebook at Enlighten Education Limited. I'm on Facebook. Good. Bye-bye.